Our today's concept is about Internet Control Message Protocol. That is nothing but ICMP. So in this tutorial, we will learn about how to craft an ICMP packet by using Python's KP module. What are all content or exist in ICMP header? We will look into it, and we will demo how we can craft this packet by using this KP module. Here, let's see our detailed agenda today. So, what is ICMP protocol? What are all which exist in ICMP packet? How to craft ICMP packet in Python using KP module and demo. And we quickly wrap up with what next discussion. So, without wasting time, let's jump into your session. So, what is ICMP? So, it's ICMP is nothing but Internet Control Message Protocol, which is actually network layer protocol. Basically, this is used to diagnose or troubleshoot the network management. The good example for this ICMP protocol is ping. So you might have heard this word ping. You might have done this ping multiple times in your command prompts. So this ping utility basically, which is a ICMP echo request and replay messages. To give you a brief introduction on ping, ping perhaps is the most commonly used tool to troubleshoot a network. So the ping, right, is a packet internet grapher. So this packet internet grapher is the abbreviation for ping, is included with most operating systems. It is include or invoked using a command called ping, and it uses the ICMP protocol. So in our session, to describe this ICMP protocol as a demo, we are going to use this ping utility as a demonstration. So basically this ping works by sending an ICMP echo request, that is what we are going to craft message, to the specified address. It could be some ping space www.google.com or something else. So if computer with the destination IP address is reachable, it responds with the ICMP echo replay message. So this is what we are going to achieve in this current today's session. So we are going to send a ICMP request and we are expecting back a reply, and we are going to pass this reply message by using this some third-party tools called Wireshark. Hope you understand, right? What is ICMP and we can use. Okay, let me tell you one more thing here. Basically, most of the people will think that ICMP is also one of the protocol like UDP and TCP in layer 4, right? Basically not. These ICMP messages will be encapsulated in IP packet, but not using the net transport layer protocol. This is the packet, this is a message which will be encapsulated, circulated, covered by IP packet. So this is not a layer 4 protocol, this is a layer 3 protocol. You should consider like. Hope you understand what is ICMP. Let's see how the ICMP header will look like. If you see this ICMP header, there are total 4 fields. One is type, another one is code, checksum, and remaining header depends on the type of the message, type of the ICMP message. So the first field, right, the type, the first byte, it specifies the type of ICMP message. For example, type 8. So number 8 is used for ICMP request, and type 0, right, 0 is used for ICMP reply. So these two are the values now we are going to use in our demo. So we use type 3 for destination unreachable messages as well. So we are not going to demo that right now. We will stick to type 8 and type 0. So when you check the type 8, these fields will change accordingly. If you set type 0, these fields will change accordingly. And the second byte, right, called code. specifies what kind of this ICMP message it is. For example, the destination unreachable message has different 16 kinds of different codes. We're not going to describe them because it's not a networking course, it is a Python course, so we're not going to discuss anything more. Just to give you some understanding on ICMP, I'm telling you these words. So when you see code 0, it means that the destination network was unreachable, while code 1 means the destination host was also unreachable. Is getting confused? Okay, while we're demoing, I will show you how these codes will look like and when we actually will see that code into effect. So this start field, right, 2 bytes that are used for checksum to see if the ICMP header is corrupt or not corrupted. You understand, right? So basically this checksum value will be used to validate the ICMP header. Okay, so I think we have covered what are all fields exist in ICMP, right? Hope you got some idea. Okay, these are all the fields which are available in ICMP header. We are going to craft this ICMP header by using SKP module in Python. So this is what the example which I just now spoken about. So if let's say this router 1 wants to send a ping request to router 2, and if router 2 is at 192.168.12.2, right, you just need to use the utility like ping, which actually send an ICMP request, which in turn router 1 will receive ICMP reply from router 2. So the output of the ping will look like this. And if you capture the packets actually by using a third-party tool called Wireshark, you will come to know, or you will come to see these two packets in that Wireshark tool. So the first one is indicating that the type equal to 8, and the request is this is kind of ping request. And if you see, right, type, code, checksum, and actual data, so these are all the fields which are actually present in ICMP header. And if you see, this is the reply packet which is using the type equal to 0. So type 8 is for request and type 0 is for reply. And checksum, and then the data, actual data. Okay, so we are enough with the actual theory concept, but we are much interested in demoing the practical concept, right? So for that, we are choosing a Python as a programming language and SCAPI as the module to achieve the same in demo. So hope before getting started this session, demo session, I hope you are all installed with a Python 3 package and SCAPI module as well. So my system is already installed with Python 3 and SCAPI module. So I'm going to show you the demo how it will look like. So once you install the SCAPI module and you set the path perfectly or correctly in your system, you should be able to enter into SCAPI interactive shell by simply executing this SCAPI command. Got it, right? So once you enter into SCAPI interactive shell, all the modules which are available in SCAPI will be available here. Let's say ls. So if I want to see what are all the fields that are available in ICMP header, I just need to execute command ls and the protocol. So if you see, there are many options which we haven't seen in our actual ICMP header, right? There are many options which are actually provided by SCAPI module. Maybe these are all hidden fields in the ICMP header which we have seen in the slide, but we majorly need to focus on whatever we have seen on the ICMP header in the slide. So we need to concentrate more on this type, code. I think those two are enough for us. Let's see how we can actually create an ICMP packet by using this SCAPI module. So let me create an object for this ICMP first. So this line indicates that we are creating an ICMP header packet, and let's create an IP packet as well, because ICMP will be encapsulated into IP packet. And now let's assign some source equal to my current system's IP. So my current system IP, I already know that 192.168.1.204, and the DST. So the destination, we are going to use the google.com, to whom we are going to send a ping request. Okay, now set ICMP dot type equal to 8, because this is a request packet, right? And ICMP object dot code equal to 0. So code value inserted in ICMP header as 0 for ping packet crafting here. So this is the overall packet. Let's see how this packet looks like. So you know, right, this slash operator will be used to bind the multiple protocols. So when I execute this dot show function, it actually will return what are all the options which we have just now assigned here. So the source is 192.168.1.204, which is my local machine's IP address, and destination is nothing but google.com, to whom we are going to send a ping request. And this ICMP type, it is echo request packet, and code equal to 0. Hope you understand what we have done so far on how we can describe or show the current packet. And we can also see the summary of the packet by using this summary function, which will just show you the brief introduction of what this packet is about. So it's ICMP packet from the source to the destination google.com, and it's a echo request. The code is 0. Right? Hope you understand till now what we have done so far. Now we need to send the packet. Till now we just have created a packet, but now we need to send a packet. To send a packet, we are going to use this send. If you remember these four functions from our SCAPI tutorial, send is to send a packet at layer 3, and it will just send a packet. Remember that. Send will just send a packet. It won't wait for any reply. You understand, right? Okay. Before the sending packet, let me open a Wireshark window where we actually can capture this packet. So this is the ICMP packet, right? Let me filter the Wireshark with the ICMP. This is not our packet. Let's clear this. So this, just now I cleared it and there is no packets, and let me send the packet so that we can capture in Wireshark. Here this is the command which I'm going to use, send. If you see, sent one packet, so that means one packet got sent. And if you see here, this is the packet we just now have sent. If you elaborate this packet, we should be able to see what kind of packet and what are the options we have sent just now. So here the protocol in IP is ICMP, which is correct, which we have set, and source is the word which we have set it, and the destination is nothing but basically it did some DNS resolution for the name which we have assigned, that google.com, and we converted it into IP. And if you see, this is the echo request and code is 0. Actually we are expecting some reply here which is not came. Let's see what is the actual IP of my machine. I think IP is something different. Let me open my network preferences so that I can see my IP address, or I can simply use, right, I can use this I can open new command window. Oh, okay, my machine is a little slow. Command prompt, I'm opening command prompt. I can issue this IP config, where I can see my IP address. Here it is. So my IP address 192.168.1.201. Okay, sorry, I said it wrong. Let me change it in our example. So IP dot source is 201, and if you see this IP slash ICMP dot show, should reflect here. Yeah, it got changed. Now send the packet, this IP slash ICMP, and make sure that you have cleared this and to capture freshly. So send the packet, one packet sent. Okay, here you got, right? So if you see, this is the request packet which we sent to google.com, and I got a reply back from Google to my local machine. So here you can see the first one is the packet which we sent, the request packet. And if you see this here, ping reply. So the ping reply which we got from the Google server. And if you see this correctly, the checksum is 0x0000. It should be actually this one. So there is something went wrong which we actually need to dig much more to actually see what went wrong. So this is actually not a valid transaction, but this is how the ping request and reply will work, right? So this is how you actually can craft an ICMP packet. Hope you understand how we can craft an ICMP packet. So this is the basic example which we just now seen to tell you to print some values. So if you want to print any value from the reply, so there is a way that we can send the packet and receive the packet by using a SCAPI module itself, and we can pass the received packets as well. So in our previous example, we just now have seen that we just sent a packet by using this send function, right? But instead I can use this send sr1 function, which actually send and receive the packet. If you see here, send and receive the packet, and this one means the first response should be received and returned. So sr1 of IP slash ICMP, which actually will send a packet and it will receive the packet. You have seen here, right? So here you have received reply, right? Now by using the SCAPI module's sr1 function, we are going to receive that reply on the terminal itself. So when I send this packet, this is the begin emission, and it sent one packet and received four packet and got one answer as well. Let's see what are all these outputs we just now have received. So if you see this, this is the protocol ICMP, and checksum this, and source is, if you see this properly, source is nothing but the Google one. So it is a reply, and here you can see the type is reply, and destination is my local machine. That means we have received this response that is called answer from the remote machine. So now if you want to fetch any value from this output, you can simply use this uh, object of that sr1 function, and you can just use that dot symbol to get the options, to get the output whatever you wanted to get. And if you want to check, if you want to get proto, you can simply use this proto. Or if you want to get the output of ICMP fields, right, you can simply type like this, PICMP of type, it's 0. You remember, right? Echo reply is nothing but a 0. Echo request is nothing but a value of 8. Hope you understand. That's all for this session. I hope you all enjoy this session, and you understand the most from this session, and you have learned how you can create an ICMP header packet by using this SCPy module, and how we can encapsulate that packet into IP layer, and how we can send the packet, ping packet, and how we can parse the response of ping replay, sorry, ping request and replay, and how to pass the ping replay and all. That's it for this session. Thank you. We will see you on the next session. Thank you so much.